Let's lock in a few concepts. Because the values of a and b are multiplied, we often call these factors. Their values revolve around the number 1. Think of the number 1 here as 100%. Let's begin with the parameter a, which is the vertical factor. Remember, a vertical factor operates on the y-coordinates only. If the factor is larger than 1, then the factor behaves like a percent that elongates all the y values of the parent function. For example, 2.0 is the same as 200% and will increase the values of y by the factor of 2 each. Or in other words, will double the value of every y-coordinate. If on the other hand the factor is less than 1, this acts as a contracting percent to the y-coordinate, which makes the y-coordinates shorter. For example, if the factor is 0.7, this behaves similarly to 70%, so it will cut every existing y-coordinate on the graph to be 70% of its original length. This is also why if you don't want the curvature of the function to change at all, then you want the vertical stretch factor to equal 1, which means 100% of the original y value. This is just the original value you had in the parent baseline function in the first place. These changes have the visual effect of stretching the parabola to either thinning it or bloating it wider horizontally, depending on the percent being larger or smaller than 1. Or rather, if the y values are increased or shortened. Even though the transformation is vertical, the visual effect appears to be horizontal as well, but this is a visual illusion, not an algebraic fact. This horizontal illusion, for example when looking at the left side of the screen, is due to the fact that at any given y the x-coordinates of the transformation appear to have gotten closer to the vertical axis, even though the only change that happened was to the y-coordinate. Nothing happened algebraically to the x-coordinate. The illusion appears as if a contraction of the x-axis happened. We see the same phenomenon on the right side of the screen. It looks like an expansion of the x-axis occurred. When examining any y-coordinate, it seems that the x-coordinate of the vertical stretch has moved the x to the right, even though algebraically nothing was applied to the x-coordinate. When looking at vertical-only transformations, it is a mistake to track the x-coordinate. Attention must be given to the y-coordinate. The entire premise of this horizontal illusion is due to the fact that the transformation is not moving points between the two horizontal positions. No horizontal changes are happening here. The change of the vertical-only transformation is between two vertical coordinates as shown here. Naming the stretch transformation. Let's look at the way a vertical stretch behaves. When stretching the graph in the vertical dimension, the length of the y-coordinate is either increased or decreased. This change in length is in relation to the x-axis because we think of length as starting from 0, which is right on top of the x-axis, and stretching away from it for some distance. Therefore, this vertical stretch of the y-coordinate is pivoted around the x-axis. And for this reason we say such a stretch is about the x-axis. Similarly, a horizontal stretch of the x-coordinate is at a distance away from the y-axis, and we say it is about the y-axis. To properly qualify any stretch by its full name, you must use both dimensions correctly, the coordinates stretched, and the axis about which this happens. Frequently these transformations are referred to by only one of these names, and you must automatically infer the other. This naming can initially feel confusing. But if you consider the fully qualified name of the transformation to have a first name and a last name, you can stick to the following pattern to be consistent. The first name is always the dimension of the stretch. This is going to either be vertical or horizontal, depending on the coordinate we apply the factor to. Y for vertical and x for horizontal. The last name refers to the axes in which the visual effect is seen. This is the part that contains the word about and the name of the axis. In other words, The first name states a stretch in a certain dimension and has a last name using the about the opposite dimensions axis. For example, if a transformation is mentioned to be a vertical stretch, you must conclude it is about the horizontal axis. However, if the stretch is said to be about the vertical axis, then the transformation is always concluded to be a horizontal stretch. For this reason, no vertical stretch can be about the vertical y-axis, and no horizontal stretch can be about the horizontal x-axis. Noticing that the first name and the last name of the transformation are always opposite of each other will help you keep things tidy.